Hello, today we are doing Chapter 1, Section 5, Parent Functions and Transformations. Today's date is today. Our objective is to identify, graph, and describe parent functions and transformations. So, first thing is you need to know these parent functions. These are the most basic functions that there are. And if I say linear, you should automatically be able to picture this in your head, a line with a slope of 1. If I say y equals the absolute value of x, you should be able to picture a V shape with it increasing with a slope of 1, with it decreasing with a slope of -1. Same thing with y equals x squared. You should know that that is U-shaped. Y equals the square root of x. It's going to start at 0, 0 and go sideways. Cubic and behavior, left-hand side down, right-hand side up. Cube root of x. Exponential function and a log function. We're not going to use those quite as much right now. Same thing with these two. We're not going to really use these very much, but you should take a look at them. Y equals 1 over x and y equals 1 over x squared. This one doesn't come up very often. It's the greatest integer and a constant, which is just going to be a horizontal line. You might need to hit pause and go back over some of these again. I'll scroll down again, and you can hit pause as it goes. All right, transformations. That's where you just take that function and you move it. So we're going to have some function f of x. We don't know what that function is. It can be any of those parent functions. So that's why we're just saying f of x. That h, if it's paired up, tells you the right or left. If it's a minus sign in front, it's going right. If it's a plus sign in front, it's going left. That k tells you up or down. If it's a plus sign in front, it's up. A minus sign, it's down. We're also going to be dealing with horizontal and vertical stretches and shrinks. On this one, we've got a vertical stretch and shrink. Our parent function is what's in gray. So this is a quadratic. And if you've got that 4 out in front, you've got a vertical stretch. It's stretching it up. The vertical is being stretched up. But you also notice that horizontally, it's being shrunk in. It's getting skinnier. If you have a number out in front and it's less than 1, you're going to have a vertical shrink. It's being smushed down. But if you notice, the horizontal is getting fatter, so that's a horizontal expansion. It's getting fatter, it's getting wider. So a horizontal stretch. So on this one, we need to describe the transformation. And if you did not know how to do any of this, what you could do is make a t-table. A t-table is always an acceptable amount or acceptable approach if you don't know. But I look at this and I go, hey, this isn't square root. I know what a square root looks like. And then I'm going to notice a couple different things. I've got that -2. That means it's going right 2. That +4 means it's going up 4. And that negative sign in front means it's a flip over the x-axis. So if I were to graph it, and I did this on the computer, this is what it would look like. This is my original function in orange or yellow. and then it's being shifted to the right 2, up 4, and flipped over. So that purple line is what it would end up looking like. On the next one, I've got a cubic function. I notice I have that negative sign. Actually, let's ignore the negative sign right now. We'll just concentrate on that 1/3. That negative sign has gone away, so we're not going to worry about that, but it would have been a flip otherwise. That 1/3, that's going to make the graph a little bit wider, a little bit fatter. I'm going to get a vertical compression, vertical shrink. And that -1, it's in with the parentheses, so that means that it's going to be shifted to the right one. Shifted to the right one, vertical shrink by a factor of 1/3. Let's take a look. And that is what that graph would look like. My yellow is my original function. That's the parent function. And it's kind of hard to see on this one, but it is being compressed by a factor of 1/3. And right there's my turning point. That turning point has been shifted to the right one. What I would suggest you do, take a second, hit pause. Try graphing these on your own. Ask yourself, what is my parent function and what is happening to it? When you're ready, hit the pause and check your answers. All right, on number 3 here, my parent function is just an absolute value. I've got it, it's being shrunk by a factor of 1/2. Another way to look at that is I'm multiplying all my y values by 1/2. Then I am shifting that to the right. I'm shifting that to the left 2, down 3. So my vertex went from 0, 0 to -2, -3. And my slope went from 1 to 1/2 and -1/2. On number 4, my parent function is a parabola. And on this one, I have a 2 out in front, and that 2 is greater than 1, so that's going to be a vertical stretch. It's going to get longer and skinnier by a factor of 2. And this is going to be going to the left 3. So my vertex went from 0, 0 to -2, or -3, 0. All right. Remember, Desmos is a great way to graph all of these. Just go to desmos.com. Know those parent functions. If you're still having trouble, come into MathLab or IPASS.